So maybe just to introduce Zalando first a little bit. We have been around for some 8 years, so it's actually a fairly young company. However, we've already grown tremendously. And you see all these big numbers on the slide. Actually, the numbers are higher, so this is already slightly outdated. So we're now at 14,000 employees. We're based in Berlin. We have tens of millions of active customers, and we operate in 15 countries. Because we're such a big company now, we actually generate tons and tons of data. And because of all this data, we founded a research department within Zalando. So this research department now consists of 15 people. I'm one of them. And we work on data-related topics all the way from computer vision, I mentioned some projects earlier, computer vision to text analytics, right? And of all these numbers on the slides over here, the one that we're interested in most in this presentation is the 15 countries, yes? So I mentioned this before. So we operate in Europe, and if we are active in 15 European countries, we're going to have a lot of different language data. So our customers are going to speak a whole bunch of different languages, are going to generate data in this language, in these languages, and we're very interested in analyzing this data, right? Oh, cool, thanks. Is there like a clicker or something? Nah, okay. Okay, so let's dive in. Yeah, so this talk is structured in two halves. So in the first half, we're going to talk about text data and fashion. So it might surprise some people, it certainly surprised me, that there is a lot of text data and fashion. So we're going to talk about what kinds of data are there, and why do we want to analyze it, yes? And then we're going to talk specifically about one text analytics task called named entity recognition. I'm going to talk about what it is and how we do it, yeah? And so the first part is going to be all in English. It's going to be all English data, English language data. In the second half, we're going to look at multilingual text data. I'm going to talk briefly about why this is so difficult and why we want to do it, and how we actually do it. Yeah? Okay, so text data. Let's talk about some Zalando text data that we have. So one of the text data sources are user queries. So you see that in the corner over there. So people navigate to our website and they enter in a search term, which very briefly describes what they're looking for. So it could be something like, you know, sneakers in white with a yellow stripe on the side. It's typically very short, very succinct, but very to the point. It's very descriptive. So this is very interesting text data because it shows us what kind of stuff our customers are looking to buy. And it's also very interesting for a text-to-image research because when people issue a search query on the web page, they get search results which are mostly represented by an image, right? It's going to be like a list of shoes, let's say, with different types of shoes maybe. And then after issuing the query, the user goes down and is going to make a click on one of them, probably. So, and if the user makes a click, we can associate this image data from the result with the search query that the user issued, right? So this gives us tons and tons of text-to-image data that we use for a lot of text-to-image research. So it's a very interesting data source for us. Another thing that people do is they give us direct feedback in terms of, in textual terms. So this is purely textual data. They, for example, they can leave reviews on the web page. So they bought something, let's say a shirt or a shoe, and then they write a review of what they liked about it, what they didn't like about it, what they liked about the service, what they didn't like about the service. So these examples are actually very short. They tend to be quite long. So people write these long stories. I bought the shoe and I wore it to my brother's wedding and everybody said it was nice and blah, 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 blah. So it's like all this information, right? And this is actually really interesting for us because we want to know what our customers liked and what they didn't like about the products and the service, right? Super interesting. Another type of data, so if we look beyond Zalando data, yeah, if we look to the World Wide Web, we're going to find that there's a universe of fashion out there. There's an army of fashion bloggers, online magazines, Instagrammers. So here's some examples. This is from a blog post, right? One of many, many fashion blogs. And this post, for example, is about a person that bought a dress in Berlin, randomly walking through the streets. And then she writes 2 pages of basically stuff related to this dress. Like where she wears it, with what she pairs it with, and all this stuff. And there's comments under this blog post as well, right? So people comment, oh, this dress is so nice, blah, blah. So there's so much text data. Another thing that's interesting are social media. As always, social media is very interesting. There's Instagram, for example, and other social media channels where people focus very much on fashion. So this guy, for example, he bought a shirt or something. And he's super happy about it, and so he's posting, I bought this shirt from blah, 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 and I wear it every day, and stuff like this. And of course, by themselves, if you just look at these individual data points, just one data point by itself is maybe not that interesting. But if you look at the big picture, if you look at people from certain places that discuss certain types of fashion or certain types of trends, then it becomes actually very interesting. So one of the things that we're doing, one of the big projects, is something called the Fashion Insights Explorer. Kind of looks like this, and it's a large crawling architecture. So we crawl the web, we aggregate data from social media, from our own Zalando data, and we get all this data together, and then we run text analytics over this data on a daily basis. And that allows us to for example, chart time graphs. So what trends are people referring to? How does this change over time, right? So it could be, for example, that in Paris, suddenly everybody's talking about this brand or about this style because some celebrity was wearing it, right? And this could be like a sudden shift in the trends that we are very interested in knowing. And so this kind of data that's aggregated from all over the place is interesting for us for several reasons. So one of the reasons is that this data could help our decision-making process, right? So if the styles suddenly change or the trends change and something spikes in this region, then we want to know this for our decision-making processes. Another thing, going back to the chatbots I mentioned earlier, is that this is essentially a knowledge base of fashion that is constantly being updated automatically. So in this chatbot, for example, if a user says, okay, I'm going to data natives in Berlin, so what should I wear, right? Then this chatbot could say, okay, well, in Berlin, people prefer this and this style, and you're going to a conference, and in conferences, people wear this and this style. And then it could actually draw from this knowledge base to produce an answer for you. And this is essentially why we're doing all this stuff. So if you want to get from textual data to nice little graphs like this, you need to do text analytics. And one of the tasks that I want to focus on is called named entity recognition. So in named entity recognition, essentially what you have, you train a program, in our case it's a neural network, to take text and identify entities of interest in this text. So here's an example of that. So you have a blog post, for example, where this person is writing a whole bunch of stuff, but in this text she makes reference to certain cities. So she references Berlin quite a lot. It's highlighted blue, but she also mentions Paris, she mentions Winnipeg, she mentions a bunch of different cities. And so this named entity program should identify all the cities in the text for us. It should also identify all the person names. So there's a person name in there, there's names of items of clothing, there's trend names, there's brand names, and all of this thing should come out of the named entity recognition process, right? So it's a neural network that takes text and identifies entities in this text for us. And if we can do that, the good thing is we can then do correlations. For example, we could say which trends are often mentioned together with which cities, or which brands are mentioned together with which sentiment. Do people like this brand? Like, are they talking positively about it or negatively? So this kind of stuff, right? So in order to actually build a named entity recognition system, we need two things. So the first thing is that we need is training data. We mentioned this before. So we need high quality training data that kind of looks like this. So where a human already went through the text and marked up, this is a city, this is a trend, and this is a brand, right? And we need a lot of this data. And this is actually quite challenging. So if you look at this sentence over here, this is actually a representative sentence, like if you just crawl the web for fashion-related stuff. This sentence is pretty hard to read. So you actually need to be, I would say you need to be a domain expert in fashion to be able to assign the correct labels to all the colored words in this one. So what's lateral, multicolor stripes, so what is all that stuff, right? So it's pretty hard, so you have to be an expert, right? So we needed to first identify all the entities that we're interested in, like I said, brand, look, trend, person, blah. And then we needed to create a bunch of training data for these entity types. And as I said, it's very challenging because the language is kind of weird. Or it's not weird, but it's at least, it's very creative. And in social media, it's very ungrammatical too. So it's pretty hard. But we did it. We created a very large training data set for English. We established a type system of 15 entity types that we're interested in. Created annotation guidelines, we hired experts, we trained them. We went through this whole thing, and it was a very expensive and time-consuming process, right? So so remember this because we're going to come back to this. Producing this data set for English was really expensive, but we have it now, right? So now we have this training data set, and now we're going to train a neural network. That part is easy in a sense, so because once you have the training data, you can just feed it to your neural network. In our case, it's a hierarchical recurrent neural network that kind of looks like this. It has basically two hierarchies. On the bottom, let's focus on the bottom first. You see these three groups. So each of these is a word level representation. So it looks at each word by itself in a sentence and looks at it character by character, and from this word generates a word representation together with external resources. So this word representation, like the colleague mentioned earlier, might be like a word like cat, might be represented in some abstract way in some feature dimension, the semantics, right? So we have a word level encoding of these semantics, and then each of these word level things we feed into a second recurrent neural network that's on top of it that basically takes care of the sentence. So now we have the words, and now we look at the sentence, right? And then for each word, it's a sequence labeling problem. So for each word, there is a prediction that's being made, basically up, down, goes to the sentence word by word, and it says, okay, this is an entity, and which type of entity, or it's not an entity. So this is essentially how this works. It may look a little bit complicated, but it's actually a super simple architecture. And just out of the box, we get extremely competitive results. This is not yet optimized, so numbers, we very much expect these numbers to go up significantly still. But already we're at the state of the art for English, and we beat all the published numbers for German that I could find. So it's a very powerful architecture. So neural nets are your friend here. Okay, so that basically concludes the first part. So we have the training data, we train the network, we predict the entities, and then we do the analytics. So no problem, right? So for the second part, the question now is how do we do it in a multilingual setting? So why do we even want to do multilingual? So let's look at the Zalando languages. Yes, you see all the way over there, the Zalando languages. Our data, a lot of our data is in German. That's historically because we started in Germany. Also because Austria and Switzerland are big markets as well. So there's a lot of data in German. Then there's like a second group of languages that's really important to us. That's basically neighboring countries. That's Italian, French, Dutch, and Polish are super important to us. And also we have very significant amounts of data in all these other languages. That's Spanish, Swedish, Norwegian, Danish, Finnish, and English, essentially all the markets in which we operate in. And so we want to be able to understand the reviews in these languages. We want to be able to understand people doing social media in these languages. Because if we want to know what's the style in Madrid right now, obviously we want to be able to understand Spanish, right? So what makes all of this so hard? Well, the problem, as I mentioned earlier, is that generating the training data was painful, right? So it was a lot of work to generate the training data for English. And if we want to train a system to, let's say, do this for German, we would have to go through this entire process again, months and months of work, right? And then we would have to do it for the next language and so on. And we really don't want to do that. So the question is, can we find a better way to automatically generate training data for a new language? And I'm going to, with my remaining time, sketch a solution of how this can be done. We use a process called annotation projection. So annotation projection kind of works like this on a high level. Let's say you have, so the starting situation is that you already have training data for one language, and you want to generate training data for another language. Yeah? So let's say we have this English sentence: in Berlin, I paired this dress with a moto jacket and my Uriah ankle boots. There are 3 fashion entities in here. There is it's a location. We have 2 nominal products, a dress and a moto jacket, but we also have a named product, these specific boots that are mentioned in this text, right? And so now what we do is we use technologies from machine translation and automatically translate the sentence into German in this case. Yeah? And this technology, it gives us a translation of the sentence, which is not perfect. Remember, machine translation is not perfect, but it's going to be like an okay rendering most of the cases of what the sentence is in English. And it also gives us these word alignments, essentially which word or which sequence of words was translated as what in the target language. Yeah? And so now the easy step, it's actually super simple. So the only thing we need to do now is take these annotations from English and just project them onto the German sentence as well. Right? So Berlin was translated as Berlin, so it's probably also a city. These specific ankle boots were just translated with their original name, so that's probably also. But if you look at dress, was translated in German as Kleid. But they are connected in this graph, and so we can just transfer the annotation from dress onto Kleid. Yeah? And so this is super nice, because now what has happened is that we have generated a German sentence with labels that we can use to train the neural network. And the cool thing about it is that this costs us nothing. So if we have 100,000 training sentences for English, we can project them into German just like that. And we can do it for Spanish, and we can do it for Polish. We can do it in all languages. We can do that in like a day, right? And then we have training data for all the languages that we care about. The training data is not grammatically perfect, and there may be some projection errors. There's a lot of things that can happen, and this is like the most basic way of this approach. Obviously, there's more stuff that you do in order to increase the quality, but generally the quality will actually be surprisingly good, and it will be good enough to actually train a neural network, right? And as we discussed earlier in the panel, now we have these training data for all the languages that we care about. We basically just take it and feed it into the exact same neural network architecture that we had before, that does character-based models. It learns, hopefully, everything that it needs to know from this training data. And then it can do state-of-the-art named entity recognition across all the different languages, right? So a final comment. This approach, I focused on one task here, named entity recognition, but this approach is actually usable for other tasks as well. So for instance, we have in the past used it for a task called shallow semantic parsing, which is in many ways much more difficult than named entity recognition. And even here, this approach actually worked really well. So this is useful as a general strategy for multilingual text analytics. Project and then train your network on the projected data. If you're interested in this kind of stuff, we have some resources. So we're pretty big on open source at Zalando. So if you're interested in annotation projection, we have partially released this framework as open sourced. It is called ZAP, Multilingual Annotation Projection Framework, on GitHub. Check it out. We'd be happy to hear your experiences with this stuff. If you're interested in multilingual semantic parsing, there's the Universal Proposition Ranks project that you could also check out. And that's it. Thanks.